In section 11.2, we're going to conduct inferences about the mean of matched pairs differences. So, of course, it's a mean problem, not a proportion problem. So these will be about means, and it's matched pairs, which are dependent samples, right? All right, so I'm going to make a note of that. So when we see matched pairs, remember that's a dependent sample. And we can accomplish that a couple ways, but I mean, at its heart, it's one group measured twice, which I'm going to put right here, right? Samples are dependent, so that's one group measured twice. But students sometimes think it's only one group of people, like it has to be pre-post, before and after, that kind of thing. And it can be pre-test, post-test, before, after, but it could also be people that are related, right? So people that are related would also count, because the groups themselves, once you know what one group is, it dictates what the other group is. So if spouse number 1 is in group 1, then spouse number 2 has to be in group 2, and you're testing the difference between them. So don't think that it has to be just pre and post. It could be relatives, like brothers and sisters, or brothers and brothers, or sisters and sisters, and those kind of combinations, just for starters. Okay, so we can see that we have our standard technology piece up here where it tells us what to do in StatCrunch. And then in chapter 11, we have the same pieces we've had before, random, independent, normal, right? But we have this new piece right here. And this one's unique because this is the only time in our course that we'll be dealing with dependent samples, right? One group measured twice. And then we can see actually this is a little bit easier than the previous section. We don't have to do doubles because everything we're doing is based on the differences. So that's key for this particular one. We're working on the differences, and that will matter for how we run these tests and how we run these confidence intervals when we get there. All right. So then we see here we have our hypotheses, and it's a little bit more like chapter 10 looked. It's not, you know, P1 equals P2 or mu1 equals mu2. That'll be section 11.3. It's more that the average of the differences, D stands for differences, is 0. Matter of fact, I better put that somewhere. D equals differences. So when you see a little lowercase d, that's what it's standing for. Actually, let's look down here. Since I just said D for differences, I'm just going to make a note right here. The D with the bar. Well, we learned that when we put a bar on the head like that in chapter 3, that means it's the sample mean. So this will be the sample mean of the differences. Diff, right? Remember, D is differences. And when we see the SD, that's the sample standard deviation of the differences. And then N, well, sometimes I'll write N little d because it's the sample size of the differences, but that's fine, right? We just wrote N here. And I guess I'll just say here, mu d is the population mean of the differences. In our course, we're going to assume it's 0. Right? So all those little d's that are after everything are standing for differences. That's key. But that means that we're going to have to find the differences first. Well, except StatCrunch will do it. But we'll have to write this. We'll need to find the differences. So I'm just going to put a little star here. This is unique, right? This doesn't happen in the rest of this chapter. It happens specifically in matched pairs because the differences are what we're working on. And then this is standard, you know, same thing we've seen before. You know, you pick your picture based on what type of test you're doing. You reject the null hypothesis if your p-value is lower than your probability of a type 1 error, and we'll state our conclusion. So that part's easy peasy. And as a matter of fact, before I step away, you'll notice, as before, we're not really going to use the by hand formulas. We're just going to use technology to do them. But nevertheless, I wanted you to be aware of what those symbols mean. All right, let's go run the test. All right, So a study was carried out whether Reiki touch therapy was useful. I don't know if I'm saying that word right. Reiki. Touch therapy was useful in the reduction of mean pain level in chronic pain sufferers, including cancer patients. This is a real study. It's quite old, but it was actually done. I remember that. I've read about it in textbooks. So the pain level reported by a random sample of 13 patients before and after Reiki touch therapy is shown in the table. We are going to use the results to determine whether there was a reduction in pain level after the Reiki therapy. Okay, so first off, explain why this is a dependent sample. Well, that is one group of patients, and this is really easy to spot because it's before and after. Measured twice, right? Before, after. Before and after is classic matched pairs, right? If you have a before and after, a pre and post, it definitely will be dependent sampling. All right, now we're going to have a little bit of review here and a little bit of new stuff. So here's the thing. This is before, our before row right here. This is our after row. And this up here, the patient is just labeling. So this is patient number 1. This was their pain level before. This is their pain level after. Patient number 2. So this is just a label. So don't be excited by that. That's not, there's nothing exciting there. And then we have before and we have after. Okay, so we want to go get the differences. Now, I recognize that we are all capable of doing this subtraction in our heads and coming up with our numbers, but I want to show us how to be able to do this in StatCrunch. So let me go to StatCrunch. I'm going to type in these values. So I'm going to pick a column here. I'm going to type before, and then I'm going to type the numbers in. There we go. And then after is right here. There we go. Okay, so I want to make it so that I find the differences. And the beautiful thing about this is that StatCrunch will actually do it for us. Nice, huh? All right, so let me go show you how. So StatCrunch has instructions right here. You select stat, tstat, paired. Right, there's your StatCrunch instructions right there. All right, so let me show you how to do that. Let me grab StatCrunch again. So stat, tstat, paired. Here it is. And we tell it which our column is. And it kind of doesn't matter, but it does matter insofar as on the paper itself I said take before minus after. When I do that, what that means is that that's group 1 in the front, and that's group 2 in the back. That's all that means, right? It's kind of arbitrary, but I chose to do it that way, so that's the way you're going to do it. It doesn't really make a ton of difference, but there we go. All right, and then right here where it says save the differences, I'm going to click that little button right there. You'll see what'll happen. And then I'm going to run a test. I don't even know what kind of test I'm going to run. I don't really care. So I'm just going to say compute right now, and I'll be back to actually run the test later. But what I'm trying to get is the differences right now. So I don't need this box, and it's actually not accurate because it's not the right kind of test. But what I wanted was those differences, and it did it for me. And now I don't have to do it myself. Right? So 3, 1, 2, 3, and so on. So those values can go right here and be placed right here. Now, I recognize, again, this one was really easy. So this one was not exactly, hard to do. But nevertheless, if there's decimals or other things there, then it is a little tricky to do. And this way, StatCrunch does it for you, so you don't have to bother. And you'll notice I didn't really care about the test itself. I wasn't really running the test because I didn't set it up correctly. What I was doing was just making it find differences for me. Because these are the D's. These are the differences right here. And this is group 1 right here. And this is group 2 right here. And that's set up because I did before minus after. So now I want to do a little review. How do we find D bar, which is the mean, and SD, which is the standard deviation? Just a little review. This is the sample mean of the differences. And this is the standard deviation, technically sample standard deviation, I should say that. sample standard deviation of the D's. Right, so how do I do that? Well, let me go back to StatCrunch, because when I did StatCrunch, it found those differences and it made them their own column. These are the D's now. It calls it differences. I'm just going to call it D right there. So there they are. So you would find the mean for them like you would have in chapter 3. Stat, summary stat, columns. You say you want it on the D, the differences. You want the mean, you want the standard deviation, and you want the sample size. I mean, the sample size is pretty obvious. It's 13. You can see it right here. But nevertheless, there you have it. So you learn that D bar is 1.923 and SD is 1.605 and N is 13. It's just a little review. I mean, our final exam's coming up, so stat, summary stat, columns. That's how you find the mean and the standard deviation and the sample size for that matter. All right, now suppose we want to conduct a test of whether there has been a reduction in pain level after the Reiki therapy using a 0.05 level of significance, keeping in mind that we found the differences as before minus after. What should be our hypotheses? All right, tricky. So we know the null hypothesis. In this entire section, it's always mu d equals 0. It never changes. So you're assuming that there's no change, right? That there's no difference, right? So this would be no difference in the two groups, right? There's no difference before and after. For example, take away 4 was 0. So this person had the same pain level before as they did after. All right, and then we know it's mu d and 0 as well. What we're trying to determine is what direction do we think it's going. All right, now for that, we need to look at this before minus after business right here. So before minus after and reduction, those two words together, or those two things together, are going to combine for us. Because if we think there's a reduction in pain, we think the before group, which is in front because it's group 1, right? So this is group 1 over here. This is group 2 over here. This will be after. Right? Technically it's the same group, but anyway, you get what I mean. Okay, so I think there's a reduction. Reduction means smaller. So I think the after will be smaller than the before. Okay, so now if I subtracted the after from both sides, just as you do, you would get before take away after, and the symbol stays that way, and it would be 0 over here. And that's why it's got to be this way. If it's a reduction, the before will be bigger than the after. So when you subtract them, it'll be a number that's positive. So for example, look right here. This patient was at 6 and they went to 2. Went to 4. So their pain reduced, and that's why it's a positive number. Right? Reduction in this case will mean greater than 0. Because when you subtract 6 take away 1, that's a reduction. You end up with positive 5, bigger than 0. So that's a little weird. In chapter 10, we kind of saw reducing means smaller, so it would make it less than. But in chapter 11, you have to be careful of that because it matters which group was in front. Since group 1 is before and group 2 is after, reduction in this case will mean this direction. All right, now let's look at these box plots. Another review from chapter 3. So just to kind of look at these things before we, head towards the final. So what results do we expect from the hypothesis test based on the box plots of the before and after pain levels? So this is the pain level before for these patients, and this is the pain level after for these patients. Well, we can see that it looks like the pain's reducing, right? The max is still the max at 8, but The majority over here have gotten lower. You can see the box is lower. You can see the median is lower. Just a little reminder of what these things are. This is the min. That's Q1. That's the median right there, right? The average. Right? Median and mean are both types of averages. So this is Q3. This is the max right there. And that's different than it was for the first time because this is the min, this is Q1, this is the median, this is Q3, and this is the max. So the maxes stayed the same, but the min got lower, the Q1 got lower, the median got lower at the Q3, right? So we think it's going to show reduction in pain level because all the values other than the max are reduced, are lowered from before to after. I'm going to write that up. There. So yes, we expect the hypothesis test, which we haven't run, but just kind of looking at this, we expect the hypothesis test will show a reduction in pain because the minimum, the Q1, the median, and the Q3 are all significantly lower after the therapy than they were before the therapy.